Hello, today I'm going to be making some nitric acid to make some nitrocellulose. This is an iron nitrate solution that we have here. It's about 0.4 grams in 25 millilitres of water. This is our sulphuric acid solution, the entire remaining amount of it, which is a little bit short, and we're going to be reacting it in this conical flask. So, for this reaction, we will be adding the iron nitrate to the conical flask, and then we'll be slowly, drop-wise, adding in the sulphuric acid. It's important to know that the iron nitrate is also an oxidizer. This is important to know because our sulphuric acid is quite contaminated with hydrogen peroxide, so there'll be quite a lot of bubbling being produced. As I showed from one of my hydrogen peroxide decomposition experiments, I found that this is producing quite a lot of heat in the process of oxidizing the hydrogen peroxide. At this point, the nitric acid solution was decanted into another smaller beaker, and a few pieces of cotton were added, and nitric acid solution was left to stay overnight to react fully. So now the nitration mix has been left to stay overnight. I've set up this drying apparatus that this pump here will suck out all the air inside of this. There'll be the vacuum funnel there, where hot water will wash out all the iron nitrate that remains inside it. At this point, the vacuum funnel is switched out for a smaller round bottom flask to create a much better vacuum. After the first washing stage, the nitrocellulose looked like this. It was then added back to the vacuum funnel for another wash. This is what the nitrocellulose looked after a second washing. As the liquid being poured through the nitrocellulose was now a lot clearer, only one final washing stage was done. This is the final nitrocellulose after 3 washes using deionized water. After 3 washes and about 10 minutes of drying it, this is the final nitrocellulose we have. Now for the fun part. A roughly equal size and mass of cotton was added to the top of a beaker and was set on fire. This is roughly half the amount of nitrocellulose that was produced in the reaction. This too was set on fire. This is what remains of both ignitions, with the regular cellulose on the left and the nitrocellulose on the right. Whilst I talk about a bit about the experiment, you can see some general chemistry things in the background. The burning of both compounds resulted in the nitrocellulose burning at immediately a much faster rate, but then it slowed down a bit with general little bubbles of acceleration in burning. I'm expecting this because there was an uneven nitration through the entire mixture. So if I were to do it again, I would either use more nitric acid or stir the mixture whilst it's reacting. The normal cellulose